And yesterday we said that Wronskian also satisfies some differential equation, and which is one or less differential equation, right? So let's see what Wronskian satisfies. What Wronskian satisfies. So Ly equals to 0. L is the differential operator, and you have seen the differential operator, which is Ly is nothing but y double prime plus a1 y prime plus a2 y. The differential operator. Okay. And phi 1, phi 2 are two solutions. Phi 1 and phi 2 are two solutions. Phi 1, phi 2 are two solutions. Okay. Now what's my differential equation? Y double prime plus a1 y prime plus a2 y equals to 0. And if phi 1, phi 2 are two solutions, that means both the solutions will satisfy the differential equation, right? So in that way, what you will get? You get phi 1 double prime plus a1 phi 1 prime plus a2 phi 1 equals to 0. Equation number 8. Similarly, phi 2 double prime plus a1 phi 2 prime a2 phi 2 equals to 0. Equation number B. Okay. What is my Wronskian? How did you define Wronskian? So W is nothing but determinant phi 1 phi 2 phi 1 prime phi 2 prime, which is nothing but phi 1 phi 2 prime minus phi 2 phi 1. That's my Wronskian. That means from here to get Wronskian, the first equation has to be multiplied by phi 2. At least I can get phi 2 phi 1 prime, and this has to be multiplied by phi 1, so that I can get phi 2 prime phi 1, and then subtract. Otherwise you won't get Wronskian. So multiplying A by minus phi 2 and B by phi 1 and adding. I am doing minus phi 2 multiplication, I can add, no problem. So what you get? You are multiplying the first equation by minus phi 2. So and the adding. So I will do the first B part, B into phi 1. So I will do B into phi 1 minus A into phi 2, which will lead to phi 1 phi 2 double prime plus A1 phi 1 phi 2 prime A2 phi 1 phi 2 minus phi 2 phi 1 double prime, then A1 phi 2 phi 1 prime plus A2 phi 1 phi 2 equals to 0. Both are equal to 0, no problem. If you look at, I think these are all minus, right? This will go. So what we are getting finally? We are getting phi 1 phi 2 double prime minus phi 2 phi 1 double prime, one term, plus A1 phi 1 phi 2 prime minus phi 2 phi 1 prime equals to 0. Equation number C. So now if W is this, what will be W prime? W prime phi 1 phi 2. We write this one W phi 1 phi 2. This is the typical way mathematicians write. So we use this kind of symbol. W prime phi 1 phi 2. What will be the expression? What will be W prime phi 1 phi 2? Two terms will be there only. I am giving the hint. There will be only two terms. There will be only two terms. There will be only two terms. What is that?
minus 5 2
5 1 5 2. Then
minus 5 2 5 1 double 5.
Why other two terms are not there? Because they will be 0. Cancelling. They will be cancelling. Yes. So it will be W prime 5 1 5 2 double prime minus 5 1 double prime 5 2. So if you now look at, very interesting, this coming W prime, right? This is W prime. And this is A1 W, right? So this is W prime plus A1 W equals to 0. So now you can see which differential equation W satisfies. Just more or less, my original differential equation was y W prime A1 y prime A2 y equals to 0. If I have more or less differential equation, what will be differential equation? Y prime plus A1 y equal to 0. That differential equation Wronskian satisfies. Okay, which is W prime plus A1 W equals to 0, and the solution is Wx equals to C e to the power minus A1x. So now if you want to put boundary condition that x equals to the initial condition, we can put Wx 0, which is C e to the power minus A1x 0. Then your Wx will be e to the power, tell me what is the answer? Wx will be, I am putting initial condition so that you can get a complete answer. What the W is? W is basically based on initial condition. If you put an initial condition at x equals to x0, if you have initial condition, W is only, so see, this is a boundary problem. This requires two boundary conditions, but W requires only initial condition. So many things you are getting about Wronskian. What is Wx then? We can find the C from here, right? E to the power
Minus
e to the power minus
A1.
that's all, huh?
X.
E to the minus A1. So many answers. Any hand please. I am getting really confused. So many people are saying so many answers. Any concrete answer from your side? Any concrete answer? E to the power minus A1. E to the minus A1 into x minus x0. Then Wx0. That's all. That's the answer for the Wronskian. So that is the way Wronskian bends. So now we have learned so much about Wronskian. Wronskian plays a role. In fact, solution can be expressed. The solution function actually expressing. We can actually verify the Wronskian. If we propose a solution, if the linear independent or not, Wronskian tells us. Even we can learn so much about Wronskian. What differential equation satisfies. Even if we don't know about the solution, we can find the Wronskian without knowing the solution. Okay? How to find the Wronskian without knowing? So we can actually have Wx, or we can actually find Wronskian, and we can see how. So what actually this beauty of this thing is that if at x equals to x0, if you can find phi 1 and phi 2, because this is a function of x, say fx dx. So is it possible to evaluate phi 1 x to x0 and phi 2 x0? And it is easy to evaluate because at x equal to x0 is known. Okay? So it is possible to evaluate, and once you evaluate, these things will be known from here. And x minus x0 is known. Minus a1 is differential equation coefficient, is a numerical number. So in that case, Wx can be known only based on initial condition. And later on we will show that Wx leads a powerful load. So far, Wx didn't come in the solution. Because what is the solution for this kind of system? Your solution is C1 phi 1x plus C2 phi 2x. Or if you write alpha 1 phi 1x plus alpha 2 phi 2x. Wronskian is only coming for verification purpose. Whether the solutions are independent or not. But Wronskian is not coming in the solution. It will come when? If the system of equation is non-homogeneous. That means if I have y double prime equals to a1 y prime plus a2 y equals to bx, in that case Wronskian comes directly in the solution. That's why I have done so much about Wronskian. You have to know Wronskian. In that case, you need to evaluate the Wronskian. Otherwise, you won't get solution. So now let's look at the non-homogeneous differential equation. We show that how Wronskian plays a role to find to solve the differential equation in non-homogeneous nature. Okay, so we have the differential equation now. Y double prime a1 y prime plus a2y. You are too late, sir. Too late. Too late. Please get out. Okay, thank you. Bx. So here B is some continuous function. Okay. So this type of equation has a solution complementary function plus particular integral. We have learned it. Now the particular integral, what you did earlier, how you did it, you have to struggle for that. There is no hard and fast rule. If I put very complicated functions x2 plus sin x plus 5x squared, something like that, we need to really work hard to find out. Now we'll actually illustrate how Wronskian plays a critical role to find a generalized solution for this kind of differential equation. So that's the beauty of the Wronskian. It will be completely generalized. Now if I give a complicated function to you, even a function very complicated, you can easily find the particular integral. Particular integral is always a pain. Complicated function is easy, but particular integral is always a pain because if the function is complicated, it is very difficult for you because you do 1 by d square and all those things, and sometimes you have to do partial fractions. So many things will be happening. Sometimes you won't be able to integrate. So many things happen. You may do mistakes also. But the method we are going to cover here is a complete generic method, complete generalized method. With that, one can actually solve the system. So let's look at, let by psi p be the particular solution. Be the particular solution. And psi be any other solution. Psi be any other solution. Because we know that this has two solutions. One is complementary function and one is the particular solution. So I am saying psi is any other solution, and because we need a particular solution also, we are interested to work on by psi p. Unless you find psi p, your solution is not complete because CF you know, which is C1 phi 1 plus C2 phi 2. This solution is known. We have done already. Now we are working on the particular integral. So if it is Ly, so we can write L psi p equals to dx. Any other solution means that also satisfies differential equation. Okay. Then what actually happens? L psi p minus psi equals to 0. That means what? Psi p minus psi must satisfy the homogeneous differential equation. That means psi p minus psi is nothing but a complementary function, right? Which satisfies the differential equation Ly equals to 0. Okay, so that means what? Psi p minus psi is nothing but your complementary function. There's nothing but a solution C1 phi 1 plus C2 phi 2. Phi 1 phi 2, the independent solution of the homogeneous differential equation. Okay, so this is the homogeneous differential equation. The solution is C1 phi 1 plus C2 phi 2. So what is my psi p? My psi p is nothing but psi plus C1 phi 1 plus C2 phi 2. This is the way one can actually obtain the particular integral, particular solution. Remember that we have determined psi p. Phi 1, C1, phi 1, C2 phi 2 are very easy. We have done it already. We don't worry about much on that. But our objective is to talk about psi p, which is psi plus C1 phi 1 plus C2 phi 2. Okay. So if you look at, so now you have to find out how psi p will be. What is the generalized form of psi p? C1 is constant, phi1 is function of x. C2 is constant, phi2 is function of x. And psi could be function of x, it has to be. Okay, because it's also another solution of bx and it has to be function of x, it cannot be constant. That means the entire cycle has to be function of x, but it cannot be C1, phi1, C2, phi2 nature. Now, since it is not C1, phi1, C2, phi2 nature, could it be possible to investigate the solution like u1x, phi1x plus u2x, phi2x? Here our solution was what? C1 phi1x plus C2 phi2x. What I am saying that I am putting a coefficient which is function of x slightly higher order. Okay? Because of this nature. Because psi is a function, so entire thing, would it be possible to write? If it is possible, what will be u1 and u2? If you know u1 and u2 is okay, because phi1 phi2 are known. They are the solution for the complementary, for the homogeneous differential equation. Phi1, phi2, the solution to the homogeneous differential equation. So if they are the solution of homogeneous differential equation, phi1, phi2 are known. If you know u1, u2, then your part is solved. You got the particular integral. And if you know the particular integral, you know that particular integral plus complementary function is the total solution. Okay? So what could be the next? So this is this if it is a solution, that means this must satisfy this differential equation, right? This must satisfy this psi p, that you know that L psi p equals to Bx. Of course, we have already initially told that. If it satisfies, then you must have the condition for u1 x and u2x, and that's it. That will give you the answer. So in that case, what actually happens? Psi p we have defined as u1x, phi1x plus u2x, phi2x double prime plus a1 u1x, phi1x plus u2x, phi2x plus a2 u1x, phi1x plus u2x, phi2x equals to Bx. You can put, I am putting left hand side, it's better. Or you can, yeah, better to put, because otherwise all the time you have to write the Bx. So, before that, we can do some kind of calculations of this term. u1 phi1 double prime is nothing but d2 dx square u1 phi1. I am not writing the x because now you know that u1 is function of x, phi1 is function of x. What you can write? ddx of u1 phi1 prime plus phi1 u1 prime. Next step. What do you get? Final answer, can you give it to me? There will be three terms. 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 Yes, a bit louder. u1 phi1 double prime. Yeah. Excellent. Very good. So it is u1 prime phi1 double prime plus 2 u1 prime phi1 prime plus u1 double prime phi. Right? Similarly, u2 phi2 double prime is nothing but u2 prime phi2 double prime plus 2u2 prime phi 2 prime plus u2 double prime phi 2. So now you can see from here, each of these terms will have three terms, okay? First term is u1 phi 1 double prime. I am taking this one, okay? Next I will be taking a u1 and also ddx of u1 phi prime, you know that. What is that?
It's not u1 prime.
Just a minute. u1 phi 1 double prime, 2 phi 1 prime u1 prime, u1 double prime phi 1. What is the problem?
It's u1 prime.
u2 phi 2 double prime.
u2 prime to phi 1.
Oh. This one?
First sub. u1 prime phi 1 double prime.
Yeah, this is wrong. This is wrong, you are saying? Okay. Yes. Is that okay now? Okay. Is that okay? Okay. Sorry for the because I do a lot of silly mistake, you know that. u1 phi 1 double prime plus u1 prime phi 1 prime u1 double prime prime. Yes, everything is okay. So now here everything is fine, I guess. Here I don't like a u1 phi 1. Then okay. So you can also do a calculation. ddx of u1 phi 1. And you know that u1 phi 1 prime plus phi 1 u1 prime. Okay? So one such term I will pick up from here. So remember that these constitute three terms. I picked up one term from here. These constitute two terms. I picked up one term from here. Then I pick up one term from here, which is a2 u1 phi 1. So from each of these sets, one term has been picked up. Next is, what is next? Next is another term which is u2 phi 2 double prime. From here I will take a u2 phi 2 prime plus a u2 phi 2. So this term has one term remaining. This term has one term remaining. I have not considered. This also has one term remaining. This also has one term remaining. This term both are considered so far, right? So far how many terms we need to consider? From here one term, from here one term. Okay. So let's look at it. We have phi 1 u1 double prime plus phi 2 u2 double prime. So yes, this term and this term we are now considering. This term considered. These two terms also left. Okay. Plus then I will consider two terms, which is phi 1 prime u1 prime plus phi 2 prime u2 prime, and then from this derivative, this term is already considered. This term is remaining. Similarly, another term also will be remaining. So we have what term? a1 phi 1 prime u1, sorry, phi 1 u1 prime plus phi 2 u2 prime. Is everything okay? All terms are considered. So initially I took u1 prime u1 phi 1 double prime. So first terms I just constitute this one. Why I did it? Because if you look at, this is 0. That's why I did it. This is a differential equation. Complementary function phi 1. Okay? Because we know that L phi 1 has to be 0 and L phi 2 has to be 0 because they are the solution for the homogeneous equation, independent solution of homogeneous equation. So L phi 1 equals to 0, L phi 2 equals to 0. So this is nothing but my L phi 1. This is nothing but L phi 2. Right? Okay? Then what else is remaining? Then what else is remaining? So the only three terms are remaining. So now we'll assume phi 1 u1 prime and phi 2 u2 prime equals to 0. So if you take the derivative of that, what will you get? You take derivative of that, what will you get? If you take derivative, what will you get? Remember, this entire thing is equals to b. Right hand side is equals to b. That you always remember. Right hand side is always has to be b. If you take derivative, what will you get? Phi 1 prime u1 prime plus phi 2 prime u2 prime plus phi 1 u1 double prime plus phi 2 u2 double prime equals to 0. You can write taking derivative. Taking derivative. Taking derivative. So what's actually happening then? Is phi 1 u1 prime 0, phi 2 u2 prime 0? That means already we are assuming 0 this one, right? Remaining terms. This has to be equals to b. That means what has to be 0? This has to be down. The entire thing has to be b. Okay. So some term has to be 0. What is has to be 0? Or what has to be b? Okay. So let me write down. I'm deleting this part. I'm saying that initially we assume phi 1 u1 prime, phi 2 u2 prime equals to 0. Because of that only this term got 0. Okay. Next, I am writing phi 1 prime u1 prime, phi 2 prime u2 prime equals to b. Okay. Then what actually happens? We have the two equations. So you satisfy, you just see the check and satisfy. This satisfy the equation. Okay? This, what is that?
B is equal to phi 1 u1.
Pardon? Phi 1 u1 prime, phi 2 u2 prime, you put 0, right? Yes. Okay. And then from here you will see that you found this is 0, right? So
phi 1. So this is right. Phi 1 prime u1.
what is that?
Correct, sir.
It is, I think, okay.
It's right.
That's okay, I guess. Why confusion? No, you can ask question, but I thought something I wrote wrong.
It's right.
That's what I was thinking. Can you explain why this correct? Since we stopped, I also want to stop it.
Sir,
Yeah.
why we substituted this value? So phi 1
This is what you understood, right? This is what I assumed equal to 0. Okay. Now, what I did, I took the derivative.
Derivative is equal to 0.
So this also equal to 0 because function is 0, derivative has to be 0. No question. Now, this entire thing equals to b, right? Then
Substitute phi 1 u1 prime plus phi 2 u2 prime is equal to minus phi 1 u1 double prime. I substituted back into that.
yeah. So what will actually happen?
The two terms got cancelled. One of the
2 or minus 1 will be 1. No cancellation here. Do you want me to do it here once again?
2 became 1.
Yeah. So this, so phi 1 u1 prime plus phi 2 u2 prime is nothing but minus phi 1 u1 prime plus phi 2 u2 prime minus phi 1 u1 prime plus phi 2 u2 prime plus 2 phi 1 prime phi 2 phi 2 prime equals to b. So phi 1 u1 prime phi 2 u2 prime phi 2 prime equals to b. What we want to solve? We want to solve u1 prime u2 prime because phi 1 phi 2 are known. Which are the solution, independent solution? We have already seen the independent solution. It's not possible to obtain. How to obtain the solution from here? Cramer's rule. Determinant is what? For Cramer's rule we need determinant. Determinant is nothing but Wronskian. Determinant is Wronskian. W51, 52, right? What is U1 prime then? You know Cramer's rule, I guess. It is being taught in 10 plus 2 itself, not even B10. Can you write in terms of determinant? I am just putting like this. What is denominator? What is numerator? Who can tell me? Amit? Cramer's rule, boss. There is no excuse here. I am asking Cramer's rule only for 2 by 2 system. Even there is no excuse. I am asking Cramer's rule, which is done in 10 plus 2, right? Not only BTech math. You are struggling for Cramer's rule. Excellent. Vasudha, Cramer's rule, forgot. Nikita, Cramer's rule, forgotten. What is this? Cramer's rule you have forgotten.
On the numerator, I think
This you are actually trying to solve. U1 prime, U2 prime, because 51, 5, 51, 52, 51 prime, 52 prime all are known.
0b on the first column.
0b,
52, 52 prime.
52, 52 prime.
Divided by Wronskian.
Wronskian, what is that?
51, 52.
51, 52,
51 prime.
51 prime, 52 prime. So it is nothing but what? Minus B52 by W51, 52. Am I correct? Yes? U2 prime equals to? Now I won't write like this. You give me the final answer. B51, right? How? Just guess. Amit is very good in gambling.
51 prime.
You are very good in gambling, I said.
First column will be.
So these will be replaced by the first, second column. Zero, the other columns will be the same. So if you have Wronskian, so you know that. So this has to be replaced by 0b, and of course you can see it will be B51. Other terms will be 0. So it is B51, W51, 52. Now you can see U2 prime, U1 prime having Wronskian, right? Then how to find out U1x? How to find out U1x? How to find out U1x? U1 prime is minus B52 W51 comma 52. So what is given? du1 by dx equals to minus B52 by W51 52. What is U1? Which is nothing but B52 W51 52 dt x0 to x. That's why dt is a dummy variable. Remember that. I cannot write x here because my x is carrying limit. So if you go back to your definite calculus or indefinite definite calculus, 10 plus 2, they put dummy variable. It is not even BTech mathematics. So this is the U1 answer. What is my U2 then? Integral x0 to x b. So we should write here properly bt phi 2t. Similarly bt phi 1t. You can, if you want to be very precise, phi 2t, I can write phi 1t, phi 2t, dt. Correct? U1 you can obtain. Now we have to find out the last step, particular solution. What is particular solution then? Integral x0 to x u1x phi x plus u2x phi 2x. You give me an answer. I have given the first step. You combine everything in this integral. What is the solution? Denominator term is very easy. I will write for you. I want this term. I want this term. is the solution? Final term. Psi p equals to only two steps. You have the u1x expression, you multiply with the phi 1 plus u2 multiply with the phi 2, manipulate, get indefinite answer. That's what I'm asking for. Nothing else I'm asking. Manipulate and get indefinite answer. Manipulate and get indefinite answer. What is that, Amit? Any idea? You take so much of time to manipulate. You take so much of time. Third bench, yes, madam. Third bench, corner, yes. It is easy, no? Yes. Who is telling? Okay, please. What is that? Which of T? B is not coming, no? Where? B of T, you take common. Don't tell for everything. Okay. Next. 5 2x, 5 on T, minus 5 on x. Sign. What is my 5 on x? 5 on x equals to, what is 5 on x? Tell me. The simplest part. 5 on x equals to, we have done yesterday. 5 on x. 5 on x is given yesterday.
e to the power m1
E to the power m1x. 5 2x is e to the power m2x. Okay. So, what is your Wronskian then? W phi 1 phi 2 will be what? From here directly Wronskian. How to get Wronskian from here? Phi 1 is e to the power m1x, e to the power x, m1 e to the power m1x, m2. That's all. That's why if you do shortcut, you do mistakes. You take a determinant. What is that? X. So much things I am getting from you guys. It is m2 minus m1 into e to the power m1 plus m2x. See, the simple thing you are not able to tell me. m2 minus m1 e to the power m1 plus m2 into x. So what is phi 1x? See, numerator part. So what's the general? So psi p is a particular solution. Your general solution is psi, right? Because we know that L psi p equals to b and L psi is also equals to b. We have to find out the psi. Because, and from here we know that psi p minus psi equals to 0, and that gives psi p minus psi equals to c1 phi 1 plus c2 phi 2, and psi p equals to psi plus c1 phi 1 plus c2 phi 2. Okay, so what is your psi then? So also you can we can write this as other way. You can also write this as or this, or you can write psi minus psi p equals to 0. In that case, you can nicely write psi p plus c1 phi 1 plus c2 phi 2. Now from here, I want your answer. What is the generalized expression for psi? So c1 phi 1 is, you can write c1 e to the power m1x plus c2 e to the power m2x. plus psi p. What is psi p? The integral. You have all the w phi 1 phi 2. In w phi 1 phi 2 you can see that you are actually having m2 minus m1. So denominator part will be m2 minus m1. Am I correct? Of this integral? 1 by m2 minus m1 e to the power m1 plus m2x. Phi 2x is e to the power m2x. Phi 1s is e to the power m1x. e to the power m1t, e to the power m2t. So what will be my integral? Integral x0 to x. What will be my dt dt? Fill in the blanks. E to the power minus. That's all. T will not be there. You can write e to the power m1 x minus t minus e to the power m2 x minus t. Am I correct? Yes or no? Yes? That's better than solution. But don't use the formula. This formula if used, you can get a lot of complications. I'm just giving how to have the solution and the final solution. I will pick up one example problem now. And I will tell you that if you know this method, you can solve any such problem. You don't have to worry about. So today we have done some beautiful method. If you know this method, you don't have to worry about no particular integral. Anybody can give any kind of tough problem, you can solve with this technique. Earlier actually we didn't think about how to do partial fraction, all those things. No need to think about. Directly apply the fundamentals and solve the system. So let's look at one example problem. Let's look at the example problem and try to solve it. Yes, what's the problem? Any problem? Y double prime minus y prime minus 2y equals to 0. Sorry, e to the power minus x. This will be x. I want to solve it by this method. The characteristic polynomial. The characteristic polynomial is what? Look at the characteristic polynomial. The characteristic polynomial, after putting the trial solution, what is that? What is that? M square
minus m
minus n.
minus 2 minus 2 is equal to 0.
What roots you will get? M equals to minus 1 plus 2. Phi 1x equals to e to the power minus x. Phi 2x equals to e to the power x. Very good. Next step. Particular solution. See, now immediately we are going to particular solution. What is the particular solution? Psi px u1x phi 1x plus u2x phi 2x. How to get u1 u2? You need to solve two algebraic equations to get u1 prime u2 prime and then do integration. See, you are not using the formula. If you use the formula gone, you won't appreciate the method. If you look at the derivation, always you remember the derivation, don't remember the formula. And that's what I always do. In mathematics, first thing you do, don't remember formula. For gate exam, you can remember formula. I don't worry about gate exam. The thing is that in mathematics, first thing you remember the derivation. So that equations you remember phi 1 u1 prime plus phi 2 u2 prime equals to 0 and phi 1 prime u1 prime phi 2 prime u2 prime equals to b. These two equations we solve to obtain u1 and u2. So what will you get? What equations will be getting? Phi 1 means e to the power minus x u1 prime e to the power 2x u2 prime, right? Next phi 1 prime is minus e to the power minus x u1 prime plus 2 e to the power 2x u2 prime equals to 0. Get me the answer. Sorry, e to the power minus x equals to b. Okay, what is u1 prime then? You solve it by Krammer's rule. If you solve that by Krammer's rule, what you will get? Krammer's rule u1 prime equals to u1 prime equals to u1 prime equals to this Krammer's rule. Yes, anybody? u1 prime and u2 prime. u1 prime and u2 prime. How much? U1 prime and U2 prime? Grammar school. Where boss we are not able to do grammar school, I have just given the formula just now. You cannot do grammar school. You cannot do grammar school. You see how you are struggling to have the 2 by 2 system grammar school, not even 3 by 3. 1 by?
-1.
-1, not correct. -1 is not correct. How much? How much, madam? -1 by 3, you are right. Next is? Next is? Next is? -1 by 3 is first and second one is? See how much I am struggling to get answer from you. That to 2 by 2 system. 2 by 2 system, how much I am struggling? Many guys are not even doing, only 2-3 guys are doing. That's why I am struggling. This type of problems are going to come in the exam. What's the fancy? U2 prime. Boss, I am really getting shocked to see that we are not able to solve this problem. The 2 equations are given. You have to just use the grammar school. How much is the answer U2 prime? How much is the answer? Pardon? E to the power minus 3x by 3. You are right. 1 by 3 e to the power minus 3x. Okay. What is U1x from here? What is U1x? If you integrate minus x by 3 and U2x equals to minus 1 by 9 e to the power minus 3x. So your sin t equals to minus x by 3 e to the power minus x minus 1 by 9 e to the power minus x. Am I correct? Yes. E to the power 2x. Right? Yes or no? Okay, so we can actually get the final answer next class. So next we'll meet on Friday and we'll discuss further. Thank you for your attention.